So here is kind of a thought problem. We have two beakers, identical beakers, and they're filled with water to the same level, but one of them has a ball floating in it. All right, and then the question is, if we were to put these on scales and weigh them, a couple of screen and a couple of knobs here, identical scales even, although they don't have to be identical. Which one would weigh more in this case? Would this one weigh more, would this one weigh more, or would they weigh the same? Whoops. Preview. Let's see, so there's not really a lot of equations to do in this one. It's more of a thought problem, but still let's give it some variables here. This is big M of the water, the mass of this water, and this is little mass of the water, because one thing to realize is there's more water here than there is here. Right, the ball is displacing, is taking up some space where the water is not. There's no water in this little half sphere volume, but the level is at the same height. So that means there's more water here than there is here. Less water. That's one thing to realize. And then the other thing to think about is that this is floating, right? So if this is floating, what do we know? We know that there's a buoyant force up and it's displacing, or the buoyant force is canceling the weight of the ball pulling it down. But really the key is to think about the rule for the buoyant force. The buoyant force is equal to the weight of the volume of water displaced. Right? So we know that for the ball, the buoyant force is equal to the mass of the ball times g. But what that means is the force, the weight of that volume of water is equal to the mass of the ball. So what you have is a ball whose mass is, if you just turn it into water, it would exactly fill that volume. And then, if you were to add that to this, then this would be big MW, right? Then they would match, because it would be 2 beakers of water with the same volume. So you've really just taken some of the water volume, removed it, but replaced it with something of the exact same mass. And that's why the answer is that they are the same.